This is a solution to example 9 from the applications portion of the 1.4 notes. So this problem deals with what's called the position equation. And the position equation is used to find the height of an object after a given length of time, or the time for an object to fall a given distance. The equation is S is equal to negative 16t squared plus v naught t plus s naught. I will not require you to memorize this formula. If I want you to use it on an assessment, I will give it to you. And let me describe what the variables are. So S represents the height of the object in feet at time t. This is our function. We can think of it as S is a function of t. V naught is the initial velocity of the object in feet per seconds. S naught, this little subscript 0, represents the initial height of the object in feet. And we're going to use this equation for example 9. So example 9 says you drop a penny from the top of the Eiffel Tower in Paris. The building is 984 feet tall. How far off the ground is a penny 4 seconds after you drop it? This is the first portion of the problem. So I'm going to do that part over here. So we want to know height after 4 seconds. So for this, we just need to use the position equation, substituting in t equals 4 into our equation. So S as a function of t, I'll write that out explicitly, for our case is negative 16t squared. Now we need to know what the initial velocity is. So since we're dropping the penny, that means the initial velocity is 0. So we'll have plus 0t, and then we know the initial height, and the initial height is 984 feet. So this is S naught. So I'm going to substitute that into the position equation. So we have plus 984. This is our function. So what we want to find is S of 4. So that's going to be negative 16 times 4 squared plus 984. That's negative 16 times 16. 16 squared is 256. So it's negative 256 plus 984. And subtracting 256 from 984, we get 728 feet. So the penny is 728 feet above the ground after 4 seconds. Okay, now we're going to do the second portion of this problem. The second portion of the problem says, how long will it take for the penny to reach the ground? So once again, we're going to use this position equation using the specific information for this problem. So S of t is equal to negative 16t squared plus 984. Remember, the initial velocity here is 0, so we don't need the t term. And when the penny reaches the ground, that means the height is 0. Okay, so when penny reaches the ground, that means that S of t equals to 0. So what we're really trying to find is the time when the height is 0. So we need to solve when is 0 equal to negative 16t squared plus 984. To solve this, I would put the 16t squared on the other side. So 16t squared equals 984. Then we can divide both sides of the equation by 16. So we're going to get t squared is equal to, that turns out to be 61.5. Then we can extract square roots, taking the square root of both sides of the equation. So t is equal to plus or minus rad 61.5. But in this case, negative time doesn't make sense. So we're just going to take the positive square root. So we really just need rad 61.5, which if you enter that in your calculator is 7.84 seconds. So if we answer this in a sentence, we'll say the penny reaches the ground after 7.84 seconds.